So I'm going to be talking about a abiotic approach to marine carbon dioxide removal, similar but different to what Paul was talking about. I'd just like to thank Danny and Paul for getting Oceanography 101 out of the way. Very useful for me. And I'll be, talking about things going on the other side of Canada in Halifax, Nova Scotia. And there's a nice picture of Halifax. Anybody who's spent any significant amount of time in Halifax knows that this photo represents accurately the mean climate of Halifax. It's just sun, sun, sun all the time, like in Arizona. And more seriously, I'd like to acknowledge my colleagues and collaborators, especially Katya Fenno and Daria Atamanchuk, who have really been doing a lot of the work, and also our industry partner, Planetary Technologies, whose chief scientific officer is Will Burt, and there's a connection there. We're closing the loop here. Will's mum, Helen, used to be Associate Vice President Research here at UBC. So just thought I'd mention that. Okay, so as I think we're aware, the interest in marine carbon dioxide removal has increased dramatically over the last just 2 or 3 years, really. Whoops. And a lot of the reason for that is due to a rapid push from the private sector, which is actually raising a whole bunch of issues and questions because we haven't thought about this very much before. And the questions really include, how can science respond? What type of research is needed? And how do we do it? How can it be organized? And I think we're all facing this sort of issue. Just a little call out to the Alkaline project, which I think is a really interesting example of a response of the scientific community to this challenge. It's a multi-scale, multi-purpose, multidisciplinary, but most importantly, it's also a multi-sectoral research project, but which is also international and involves researchers. I think I must have had this on automatic, so this is going to happen. Researchers from Canada, it's led from Dalhousie University, but also from Germany and Australia. And this was put together in rapid amount of time, really. And it's notable it was done with the basis of philanthropic funding. I think all of those working on international research projects realize that putting an international research project together with conventional funding agencies takes an awful, awful long time. So there's a lesson learned there. But importantly, just earlier this year, this very nice report came out, produced in British Columbia by a couple of organizations here, which I'm keen to get in contact with, by the way. I think it's a very good report. It's a techno-economic analysis of all approaches to carbon dioxide removal, land and ocean-based. And they come down with pretty strong positive words about ocean alkalinity enhancement as being potentially the lowest cost engineered ocean CDR approach, with an estimated cost there, which, presumably is a long-term achievable cost. It's certainly not that at the moment, and with high potential for economic secure removal. But, and there's a big but, the removal efficacy is dependent on site-specific mixing and transport, requires additional empirical data validation, and especially their conclusion was it requires field trials with robust measurements and monitoring to evaluate whether it really works or not. Well, just so happens that we'd come to that conclusion 2 or 3 years earlier and initiated together with Planetary Technologies a pilot study in Bedford Basin in Halifax to test out Planetary's concept. I'm worried this is going to skip forward. Planetary's concept for ocean alkalinity enhancement, which is different than the one Paul showed, and which involves, in this case, adding alkaline materials, in this case, magnesium hydroxide, to seawater to increase pH and produce capacity for taking up more CO2 from the atmosphere. And last year, pilot scale additions of magnesium hydroxide have taken place in Bedford Basin in Halifax from a power plant outfall. And that was done by Planetary, and our role at Dalhousie was to do coordinated but independent experiments of measurement and modeling of what happens. And that's primarily MRV, but also some impacts research. We are not in any case working for Planetary, but we're working alongside them in partnered multi-sectoral but independent research. So why Bedford Basin? Why Halifax, or why Bedford Basin? We think this is a really good environment for a pilot study. And it's because it's, in a way, a prototype living lab for this type of issue. I'll say a little bit about living labs on the next slide. So it's Bedford Basin, about 8 kilometers long, about 5 kilometers wide, maximum depth about 70 meters, and it connects to the open ocean through a kind of a narrow channel. It's a fjord, and it's got the water in the basin has a residence time of varies surface to deep, but on the order of months. So that's quite useful. But most importantly, it's a data-rich environment. Department of Fisheries and Oceans and Dalhousie University have been studying it for decades. It's of manageable scale. We can actually observe it. Inputs and outputs are measurable or potentially measurable. We have an excellent model and framework available for the basin and its connections to the open ocean. So therefore, MRV may be possible there. And experiments, if you're adding alkalinity, they can be repeated. It's logistically accessible. And I think this is really important. We do all this in the full view of the public. The public's very aware of what we're doing because they can observe us doing it. Okay, so a little bit about living labs. This is not a concept, a new concept. It's been around for decades, but it's relevant to this type of challenge, I think. And it's in a living lab, various definitions, but can be defined as a physical region or could be a virtual reality, where companies, public agencies, so public-private people partnerships can be developed for creation, prototyping, validation of new approaches, new technologies, or new ideas. And it's been used in many, many areas of science and technology, as I think many of you know. So we think that is actually what we need for testing out MCDR approaches. I think the involvement or awareness of the public is really important. So what have we done so far in this little prototype living lab in our city? So we started out with some very small additions of alkalinity, magnesium hydroxide, together with rhodamine dye. Planetary did the magnesium hydroxide additions. We did the dye additions. We did 2 of those, and as you can see, we turned Halifax Harbor and Bedford Basin pink. Now, this happened in August and September of 2023. It was coincidence that the Barbie movie came out in July. However, some people really thought this was some advertising thing for the movie, but the public were aware because they could see it, from the dye. That's the color of the dye. And so what we did was we first wanted to know what would happen to the alkalinity of those added. Where would it go? And so we studied plume dispersion with the dye, but also measured alkalinity in the plume. We were able to detect the alkalinity signal, so we have some limits, and we know a little bit about how we will detect the alkaline signal in the future. And really, the coexistence of the model and the observations turned out to be absolutely fantastic for this. It's rarely done in our field where we actually do combined modeling and observation studies, but at this scale we can do it. And we actually, the model learned from the observations, which is always the case, but actually we learned from the model that how and where to observe. So it was a true interaction. And so we were able to test our techniques and improve them over the course of these studies. So the necessary components were, first of all, you've got to have a good model. And we had a ROMS model with multiple scales, which both allows us to estimate how much CO2 is taken up, but also guides and informs the field trials. And then we have a well-characterized system where we actually had a baseline on the alkalinity in the basin, and we could compare with measurements of what happened after alkalinity was added. We saw a signal, and it was detectable. And that allows us to refine the model for estimating the CO2 uptake. And what we've also been able to do is use it together with other industry partners to refine observing techniques, including some new sensor technologies and things like that. So it does all fit together. And we even had students involved and high school students involved in the project. I think that was the last slide. Oh no, I've got lessons learned, but I don't know why it's not. Okay. Lots of lessons learned, and many of them common to what Paul was talking about, but some may be slightly different. The development, so what we feel is the development of this approach requires a dedicated combination of models and observations. You can't do one without the other. You need both, and they have to be working at suitable scales where the observations can inform the model and vice versa. The cross-sectoral collaboration, the collaboration, especially with the private sector, we feel was essential. We could not have afforded to do the experiment if it had just been on research funds alone. And the ability to leverage the funding from the private sector allowed us to do the pilot scale experiment. And that's where I probably disagree a wee bit with Paul. I do agree that having independent research institutions involved is essential. But I think if we can do this at scale, we actually need to work in the right way with the private sector. And it can be done. You know, it requires a lot of discussion, a lot of communication. The priorities of the two groups are very different, and the pressures on the two groups are very different. So it's been interesting, and independence is key, but communication is also key. And then the last point I want to make, and people working in the private sector will know this better than I do, but we have an environment here where we can do research together because of the geography. However, it's not the place probably where the company is going to make a lot of money. And the investors in the company may or may not feel this is the right place to do ocean alkalinity addition, but it's the right place to do research and development. Or we feel that. And so I feel there's a real issue there in the push and pull of money, especially going to the private sector who want to do R&D, need to do R&D with independent groups. But are the investors ready to pay for the R&D that is absolutely essential for this new industry?